Let's now consider one example for using nested loop on a one-dimensional arrays. And I would say this example is also related to checking an existential property on an array, which we spoke about before. And later on, once we go to the two-dimensional arrays context, we can also check universal versus existential properties. So you may just want to review the relevant, the related slides in the previous lecture about how checking universal versus existential properties. Let's see what the problem description is. So given an array of integer, and then we want to determine if it contains any duplicates. So any, as long as there's one instance for the duplicates, meaning that at the distinct indices of the array A, so those two indices, those two positions actually store the same elements, right? So notice what I said. I said distinct locations of the array, right? We'll see that. So for example, if you got 1, 2, 3, 4 over here, you can see there is no duplicates, meaning that if you find the pairwise indices, all the possible combination of the indices that are actually distinct, and they don't really store the same element. For example, you can see you don't really compare index 0 versus index 0 itself because it's always the same. So that will give you the false alarm. So you just want to compare distinct indices. For example, you can see index 0, index 1. They are different elements, so that's not duplicates. And also index 0 and also index 2, and also index 0, index 3, and etc. You want to find out for all the combinations of the indices that are actually distinct, you don't have any duplicates. And for this one here, it would be true because now you can see from index 1 and also index 3. So this will be the violation. You can think about it as like a satisfaction witness. In this case, this will be the satisfaction for duplicates, right? So these are the examples for programming this method here. So now, are you able to simply write a nested loop to really solve the problem? Just by using the general structure which we spoke about in the previous video, you will be able to solve it. And that will be the first version I would like to present to you. However, it does suffer from some redundancy and also unnecessary checks, which I will show to you. Okay. All right, and then eventually you really want to, so that's a critical question to ask yourself. So when can you conclude that there are duplicates, right? So this can also guide you to really write the most efficient possible solution to the problem. So this will be the hints over here. As soon as we find that two elements at different indices, right? I said, I want to emphasize again, different indices are very important. Otherwise, if you only compare index 1 and index 1, compare with itself, it's definitely equal to each other, but it's not really duplicates. So if they happen to be the same, that means we can conclude there is at least one instance for the duplicates, right? You can really go over the slides, the next few slides, but I'm just going to illustrate the three versions of solution on the iPad. And then I'll point to you very quickly from the tracing table what you should really watch out for. But it will be up to you to really trace them in detail yourself. And then if you got any trouble, you can ask me in the Q&A or maybe just drop by my office hour to let me know. Okay, let's now go over the three versions thoroughly but quickly. Okay, let's see this. So this will be version number 1. Let me highlight to you. First of all, you can see version number 1. We initialize some Boolean attributes over here, Boolean variable to be false, since we are checking some existential property. So initially, we have not seen the satisfaction witness, which means we have not seen the duplicate just yet, right? That's why initially it should be false. And you will see the same initialization for the Boolean variable for all the three versions. So I wouldn't mention this again, right? Just keep in mind. The example we are looking at will be this particular array. You can see this array here has no duplicates. Let's see how version 1 is going to be traced. But before that, let me talk about the interpretation quickly. You can see here we got the outer loop, we got I here, and then also for the inner loop we actually got J. So we got I and J. So the first version I should not really say too much because it simply corresponds to the structure that we spoke about over here. Basically identical, right? Just according to the length of the array, right? So you should not be very and then for the body of the loop, rather than printing something out, we are now doing something specific to the problem. So we say has duplicates should be itself accumulated using disjunction, since we are checking its existential property, accumulated with this particular Boolean expression over here. Let's read it together. So that one is really saying the following. That one is saying, first of all, the indices I and j should not be the same, right? So that if they are the same, the conjunction should be actually false. Meaning that if I is simply equal to j, so that means, for example, we are comparing, let's say I and j are both 0. So we are really comparing a0 against itself. So 1 and 1, even though they are the same elements, but they should not be considered as duplicates. So that's why, in this case, I is not equal to j. In the case where I and j are equal, should be false. So that's going to tell you that, no, they are not really duplicates, because conjunction can just give you false. Right? It's something very important to see. And then if the indices are not the same, however, their stored contents are actually the same, so that means they are duplicates, right? So as soon as we see this has been set to true, so we will know that we got at least one satisfaction witness, and that we in theory we can conclude that the array actually contains duplicates. All right. So now let's see, for this first version here, you can see we got a 9 combination. You can see 0, when I is equal to 0, we got j 0, 1, 2. When I is equal to 1, we also got j 0, 1, 2. When I is equal to 2, we got 0, 1, 2 for the j. Right? That's good. And let's now point out what the cons are, what the disadvantages are for this version number 1. Apparently, there will be no duplicates in this, so that means we have to scan through all the 9 combinations for this particular array and then conclude that we just cannot find any satisfaction witness. In the case where the array size is very long, in that case you can imagine that, let's say, what if the array size is actually 100? For example, if a.length is simply equal to 100, in that case, how large will the trace table be, right? In that case, for every I value, and then we're going to actually check all the possible value for j, which would be 100 possible from 0 to 99. And then we have to consider that for all the possible value for I, which will also be from 0 to 99. So in total, the tracing table will be 100 squared, right? So that's something you want to intuitively to realize it's actually quite inefficient to do it this way, but at least it works. So let me point out to you why this particular solution here is bad. Okay, number one, you can see that we got 0, 0 over here, which will be checked, and also 1, 1 will be checked, and also 2, 2 will be checked as well. And as I said before, it should not be necessary for you to check that one element against itself, because they should not be considered as duplicates, right? So these are simply not necessary to be checked, right? So these 3 instances, just when I and j are equal, when I is equal to j, are necessary to check. Necessary to check. Okay, so that's one thing you should note. And then another drawback to note would be, you can see here we check to see 0, 1, and later on we also check 1, 0. Right? When we check 0, 1, 1 against 2, is it really necessary to also check 1 and 0, 2 against 1? Well, you can see it doesn't really matter which order we do. As long as we do one of them, it should be enough. So you can see 0, 1 will be enough. We don't need to do 1, 0 anymore. Similarly, 0, 2 will be enough. We don't have to do 2, 0 anymore. And also 1, 2, checking that will be enough. We don't have to check 2, 1 again. So these 3 instances are simply redundancy, right? So these are just redundant. So you can think about, for example, let me just choose one of them, one instance of them, 0, 1, and also 1, 0 over here. So these 2, for example, they will be redundant. Checking one of them will be enough. You don't have to check both. So you can see for version number 1, it's both redundant and also unnecessary in some cases, right? Especially check the index against itself. All right, so that's about one case for version number 1 when we don't have any duplicates. Let's switch to another example still for version 1. Let's see what's going to happen. Okay, let's now switch to the second example. We're still in version 1. Okay, So the code is exactly the same. So we are still checking when 0, 0, 1, 2, when 1, 0, 1, 2, when 2, 0, 1, 2. We're still doing this version here. However, so now this time we actually do have a duplicate, right? You can see the duplicates is going to happen when you try to compare index 0 against index 2. You can see the corresponding elements over there is actually 4 versus 4. So this is where we find the duplicates. So where is that? 0 and 2. So that's exactly this row over here. You can see when we actually run to the third iteration from the table, what's going to happen is you can see here. So when we got 0 and 2, so now in this case you can see I is not equal to j. Are they distinct location? They are distinct locations. 0 and 2. They are definitely different from each other. And then are they the same elements? They are in this case because it's 4 and 4. So that's why this will be true. So that means we got actually these two conditions being true for the conjunction. So that means the conjunction will be true. So now has duplication will just be true. So now we have found the satisfaction witness. And we learned about before, this will be called the zero of disjunction. As soon as you get the one of the operands to be true, the overall result will just be true. So now from this point on, has duplicate will just remain to be true over here. So you can see the drawback for is correct. However, there's a drawback here because we could have stopped. We could have stopped over here. We could have stopped here, meaning that as soon as the satisfaction witness is found for duplicates, really this part over here will be unnecessary. All the execution over here, let me just highlight them. All the execution over here would be unnecessary. Over here, it's just redundant. Okay, it's kind of redundant because you already know the result. Redundant to check further. All right, so that's about version number 1. So don't get me wrong, version number 1 is completely correct, but it's really important for you to know as a computer scientist. For version 1, we are being critical about it. We are criticizing it to say it is correct. However, in both cases where we don't have any duplicates, and also in the case where we have duplicates, there will be execution that will simply just prove to be unnecessary. You can definitely improve the version to make it still correct, but more efficient. So that's why we want to move on to maybe the second version.